Hello friends, here in this video we are going to see a problem on sectional view of a cube. The question is, a cube of 40 mm long edges has its vertical faces equally inclined to VP. It is cut by a section plane perpendicular to VP so that the true shape of the section is a regular hexagon. Determine the inclination of the cutting plane with HP and draw sectional top view along with true shape of the section. So this is the question in front of us. Just by reading it, we understood that the type of solid is a cube. So first I'll draw the diagram for it, that and explain the initial conditions. So here we have a diagram of a cube, and cube is that solid in which all the dimensions length, height, width are same, and this cube has a square top and a square base. Then since the square top and square base, they have four sides, so the square has four rectangular, or we can say rectangular, or in other words these are the square faces. So we can treat a cube as a square prism in which the height is equal to the sides. Now in the question it is mentioned that cube of 40 mm long edges has its vertical faces equally inclined to VP. So equally inclined to VP will be seen in HP. So starting with this problem, XY line VP HP. Now cube is equally inclined to VP. Vertical faces, as we see, these are the vertical faces, vertical square faces of the cube. Now those square faces, from the top view if we are looking, those will look like points and this square top will be seen. So the meaning is, since it is equally inclined to VP, it means that the cube is resting in HP, and for that drawing a light line, taking a point over it, measuring 45 degree, because since it is a square and if it is resting on a corner, or we can say the edges are inclined at 45 degree, equally inclined, it means here the corner should be there. Then the edges are of 40 mm. So marking 40 mm over on one side. measuring the distance, taking it onto the other side. Similarly, drawing an arc here, cutting it from the other side. So here we have point 1, second, third and fourth. So this is the cube in which the square top is visible from the top view, and square top, square bottom both will be on the same square. Then even the height of the square will be equal to 40 mm. Joining it with light line. Then the notation 1 dash, this will be 2 dash and 4 dash at the bottom, here 3 dash, similarly at the top. Now the condition is the vertical faces. I can say that this is vertical face 1 2 and this is vertical face 2 3, naming it over here. So this is 1, here we have 2, this is 3 and 4. Similarly at the bottom we have 1, then here we have 2, 3 and 4. So it means that the edge 1 2 and this edge 1 2 at the bottom, it is forming a triangular face. Similarly edge 2 3 is forming a triangular face. Both these triangular faces are equally inclined to VP, which is seen in HP. Then after completing this, the condition is it is cut by a section plane. This cube is cut by a section plane perpendicular to VP. So perpendicular to VP means it will be inclined to HP. That inclination will be seen in VP, so that the true shape of the section is a regular hexagon. It means first they have given us the true shape of the section, and then determine the inclination of cutting plane with HP, draw sectional top view along with true shape of the section. So for such a problem where the true shape is given, we have to make the true shape first and then adjust the cutting plane and draw the sectional top view. For that I will be explaining the method here. From 1 and 3, drawing a light horizontal line. Then similarly projecting point 4 with light horizontal line, point 2 with light horizontal line, then drawing a vertical line. Next, as I have projected these points, here I will draw the vertical line. Now I want the true shape of the section to be a hexagon. Here I am getting this corner, so this corner I will treat it as a corner of the hexagon. If there would have been an edge here, I would have treated it as the edge of the hexagon. Now how much hexagon will fit here? We want the maximum hexagon to be fitted because the sides are not given. So that maximum hexagon will be, drawing a light circle here, and here at the top I want a point of the hexagon. So this is the true shape of the hexagon, marking the points over it. Here I'll say this is point A, B, C, D, E and point F. Now I can say that point F is coinciding with this point, so this will be F here. Point C is coinciding with 2, so that will be C. Then I want A, B to be projected, and similarly E and D. For that, projecting AE. Now I'll say that where it is cutting 1 and 4, that is point A for me. Where it is cutting 3 and 4, that is point E. Similarly B and D from the bottom. So where it is cutting 1 to 2, that I'll say it is B. Where it is cutting 3 to 2 or 2 to 3, that is point D. So joining them in proper sequence. Here I'll make it dark. And here I will adjust the position of the cutting plane. It will be here, that is cutting the two edges, so we are getting 2 points. That will be A dash, B dash, and then at the middle and finally at the base. Here this will be D dash comma E dash. So joining them with the help of light line first. This will be the cutting plane. Next, as we are looking from the top, this much portion should be removed and whatever is there behind the cutting plane to be retained. So this is the cutting plane. I'll say it is A dash, and then this much portion is removed. Here we are getting the section, so drawing 45-degree lines through it as the section lines. So this is the hexagon, and here we are getting the apparent shape, that is not the true shape, and this is the true shape. Drawing the sections, section lines at 45-degree. Then I'll project the cutting plane in the front view. And that cutting plane will be a parallel line made parallel to HP, or we can say XY line. Here I am getting the points A double dash, B double dash, C double dash, F double dash. This is D double dash, E double dash. cutting plane AA dash. Next I'll be giving the dimensioning to it. (40 mm) long edges, and we have to find the inclination with HP of this cutting plane, and that inclination is, it is coming out to be 53 degrees. So I'll say that therefore inclination of cutting plane with HP, and that inclination is called as theta, that is equal to 53 degree. So this is the answer, and with this we complete the problem.